Hello everyone, my name is Samir Kumar Singh. I am PhD scholar in Electrical Department at IIT Ropar. Today I will discuss the questions for the Big 4 tutorial. Okay. So this is the question number 1. Please read it. If you have any doubt, you can ask. After a few times, we will start. I will explain these questions. So first question is the consider the following figure. Okay, which of the above curves shows a curve that considers only path loss? In these questions, we have three curves. First, the black line, second is the red, and third is the blue. We have to tell which option is the correct. We have four options. So for this questions, option A is the right. The nature of the black line is showing the nature of the path loss. Path loss, it's, that is our receive power decay with the as we increase the distance of the distance of the transmitter from the receiver. So A part is the right answer. Second question is also based on same concept. Here the question is that which of the above curve shows a curve that considers path loss and shadowing but not a small scale fading. Here we include the shadowing also, that consider the path loss and shadowing but not a small scale fading. So we have three curve, black, red and blue. Here we have to tell which have the path loss and shadowing also. So here red curve showing the nature of the path loss and shadowing both. So option B is the right answer. This question has the right answer B. This is the option of the second question. Similarly, now next question is on your screen. Please read it and try to solve. After a few seconds, I will discuss. Question 3 is the log normal shadowing has a Gaussian distribution with the variance sigma is equal to 3 dB. What should be the margin beta at the cell edge in order to ensure only 2% outage probability? Here we have the variance outage probability. We have to calculate the margin. As a hint I am giving you, just use the Q formula. There is a relation in terms of margin, variance and outage probability in the form of Q. You can use that formula. From there you can calculate the margin. Take your time. If any doubt. So this is the explanation of the question number 3. Basically, there is a relation between the outage and the margin. P outage is equal to Q in terms of beta and sigma. Our outage probability is 2%, so it will be 0.02. Sigma is given is 3 dB. We have to calculate the beta. So we here apply the inverse Q function by using the Q calculator. Q will come there and it will be the 2.054, and sigma is given is a 3 dB. Just multiply the 3 with the 2.054, so our margin will become 6.16 dB. So answer is the B part, 6.16 dB. If anybody have doubt, please ask. Okay, next question is on your screen. Question is, consider a cellular system designed with omnidirectional cells with the farthest point of the cell at a distance r. An average signal power received at the cell edge is the PRD is equal to 1.091 into P min, where P is mean is the receiver sensitivity. The log normal shadowing has a Gaussian distribution with the variance sigma is equal to 3 dB. Then the outage probability will be. Here we have to calculate outage probability. Take your time try to understand this question, and this question is related to the last question. Here we have to calculate outage probability. We have the receive power of the select user, we have the variance, we have the receiver sensitivity. So actually we have the sigma, we have to calculate the beta margin. By using this equation we will get the beta. By using that beta we can calculate the outage probability. So now we will go to the solution. Okay, so equation is given PRD is equal to 1.091 into Pmin. We have to calculate the beta margin. Beta margin is the difference between the PRD and Pmin receiver sensitivity. So firstly we will calculate the dV. So we can apply the log at the both sides. So it will become 10 log PRD is equal to 10 log 1.09 is 10 log Pmin. So margin the difference between the receive power and receiver sensitivity. So we just transfer the Pmin in that side. So this comes will be equal to the 10 log 1.091. So it is our margin. Now we have the beta, and variance is given a 3 dB. So we have to calculate the outage. So just put the value. Beta is the 10 log 1.091 and sigma is the 3. From there we can calculate P outages. It will come 0.449866. By using the Q function, we can calculate it. This is the explanation of this question. If anybody have doubt, please ask. Okay. Then now next question is on our screen. Please read it and try to answer this question. The user is traveling in a car that is moving toward the base station to which he is connected. Okay, the constant velocity is 60 km/h. User is going towards the base station with the velocity 60 km/h. At some point the user is nearest to the base station, and moments later he crosses the base station and start moving away from his base station. After few times he crossed the base station and moving away from the base station. This is the following true about the magnitude of the Doppler shift. Here we have to calculate the magnitude of the Doppler shift according to this condition and comment that which option is the correct. To just apply the formula of the Doppler shift and try to apply this reasonings on that. Firstly, user near to the base station is going to near. After some moment, he crossed the base station and moving away from the base station. Just read it. Guys, please take your time and try to answer. If anybody got answer, you can speak. Okay. So this is the explanation of this question. Okay, this is the base station. This is user is the initial position of user at t is equal to 0. User is there. After few times, user cross the base station and reach towards the far from the base station. This is the scenario. Okay, so user is going with a big velocity v. Here we break the components. Okay, so formula of Doppler shift is the Fd is equal to v cos beta upon c into fc. So we have to comment on the magnitude of the Fd. So magnitude of the Fd will change according to the cos beta. Beta is the angle. So by getting the value of beta, we can comment on the Fd. We can comment on the magnitude of the Doppler shift. Okay. So by all three terms is the constant, where v is the velocity, usual velocity, c is the speed of light, fc is the frequency, carrier frequency. So firstly we will consider the scenario of the with t is equal to 0. Okay. So consider at times t is equal to 0. User is to the left of the base station as shown in the above figure. At t varies from 0 to t1, beta vary from the pi to pi by 2. So just put the value of beta in this equation. So our cos beta become 1 from 1 to 0. It means our Fd is decreasing. For cos pi it's 1. cos pi by 2, it's become 0. So firstly from 0 to t1, our Doppler shift is decreasing. Next we are moving towards moving away from the base station. On this condition we are moving from t1 to t2 position, and beta go from the pi by 2 to 0. So cos pi by 2 it becomes 0, and cos 0 is to become 1. So in this condition FDs are increasing as user cross the base station. Okay, so first option, it decrease first when the user approach the base station, it's right. It increase as the user moves away from the base station, it's also right. So C part is the correct answer. Both A and B are the true. If anybody have doubt, please ask. Okay, next question is on display. Please read. Question is, consider a user traveling on the circular road at 20 miles per hour. Let the base station serving this user be approximately at the center of the circular road. The user experience. Similarly, this question is related to previous question. We have to tell about the Doppler shift. So option is the user experience positive Doppler shift, negative Doppler shift, positive or negative Doppler shift. It depends on whether is user traveling clockwise or anti-clockwise. No Doppler shift. So just apply that formula or apply the reasoning. Comment this and answer this question. Consider a user traveling on a circular road at 20 miles per hour and let the base station serving is usually approximately the center of the circular road. So this is the explanation of the question. Center of the road is mean the value of cos beta is equal is 90 degree. So in this case the angle between received signal and irregular velocity is the 90 degree. So cos 90 is 0. Therefore Doppler shift is always 0. From that formula we put the value of beta is the 90, so FD is the 0. Even Doppler shift is equal to 0. The answer is the D part. Next question is that we have been introduced to relay feeding, but there are certain assumptions under which is valid. Which of the following is true? Let's read the statement and comment which statement is true for the relay feeding. We have been introduced to relay feeding, but there are certain assumptions under which is valid. Which of the following is true? So for the relay we know that relay feeding have the richest scattering environment. The option A is right. Similarly, no LOS, no line of sight component, it's also true. Relay is used for the NLS component. Angle of arrival of every component is uniformly distributed. Yeah, when you drive the PDF of the you will get that. It's mostly uniform. And last part is the all of the above. So answer the D part. All three statement is true for the relay feeding. Okay, the answer is the D part. This is the answer of this question. Next question is based on a signal system. We have the 4 options. Consider a system whose input-output relation are given below. This is the input and that's the output. Which of them represented linear time variant system? So we have to check the linearity and time variant system. Okay, guys, please try. Okay, so firstly we just overview of the what is a linear and how we can check the linearity and time variant or invariant. So suppose we have the input and we are getting the output by t. So this is a relation. If xt is tending to y2 represent the input output pair of the system, then for a linear system, if x1t is giving y1t and x2 is giving y12, then ax1t plus beta x2t, sorry, alpha x1t plus beta x2 also should be give alpha y12 and beta y2t, where alpha is beta is the constant. If this condition is follows, this means our system is a linear. Similarly, for the time invariant condition, we have to shift the input function from the t0 by delay of t0. The output also shifted from the t0 delay. It's mean The system is time invariant. If it's not following this regulation, it will be time variant. So just use the pen or paper, apply to both the condition in all four options, and comment which option is the right. With a time constraint, you can check, you can apply both the condition and all options. Here, we check we pick the option 3 and apply the condition of the linearity. So this is the input and that is the output. So for the linearity, alpha x1t plus beta x2t, it becomes alpha sin t to x1t plus beta sin t and x2t. So it's just the y1t and this is the y2t. So linearity is proved. This means it's linear. For time variant, we set the input function by t naught. The xt is shifted by t naught. Xt sync function is shifted by t naught. It becomes sync t minus t naught to xt minus t naught. While output is not coming equal to the input, so it is a time variant. So option C is the right answer. You can apply both these two conditions in all options and you can check the linearity and time variant. If anybody have doubt, please ask. Thank you. So next question is given. This is the good question. Here is a question: is consider a scenario where reflecting wall and receiver are on opposite side. Reflecting wall and receiver both are opposites and this is the transmitter. Receiver is moving away from the transmitter. Receiver is moving away from the transmitter with a constant velocity v. The receiver is moving away from the transmitter, and that is the reflecting wall. So write down the equation of the receive signal. So we have to write the equation of the receive signal. What the equation of the receive signal? From this figure you can get there we are getting two terms, one from a directly from a transmitter to receiver and one with a one is from the reflecting. It's going from a transmitter to the reflecting wall. After that it's going to the receiver side. So we are getting a two terms. First one a direct term, second is the reflective term. So all options have the two terms. So basically we have the equation, we have the right equation of the both term. Please try and let me know what is the right option. If anybody have doubt in the question, you can ask. Okay. So from figure we get that we are getting two terms. Okay. So the equation is the summation of two terms, direct terms and reflected term. So firstly we write the equation for a direct term. So in the case of direct term, we have the distance, we are getting our receiver at a r0 distance and going towards the b velocity. So alpha is the gain and r0 plus b0 is distance. So we can write that there, and it's the cost 2 pi fc accepted from the 1 minus beta b upon c minus r0 of pi c. R0 is the distance and this is the Vt terms. So this is the equation for the direct term. Now for the reflected wall, so firstly the signal move from there, it goes to d, then it will reflect and then it's covered. So it will go 2d plus r0 distance. It's covered 2d plus r0 distance, and phase is also shifted. It's just opposite. So this equation replaced. So say r0 is replaced by 2d plus r0 minus sine c sine. So the rotation of the 180 degree phase shift. So here r0 is also replaced 2d plus r0. So this is the equation of the reflected part. This is the equation of the direct part. Just put the value of the both terms and we can get our equation, main equation. So option B is the true. If anybody have doubt, please ask. Okay. Next question is related with the previous one. Question is difference between the maximum and minimum Doppler shift among the all multipart component is that called Doppler shift. What is the value in the above scenario? We have to calculate the Doppler shift. Doppler shift basically the difference between the maximum and minimum multipart components. So we have to calculate the Doppler spread. So basically we all know that the formula of the Doppler spread as we used the previous initially. Sorry. This is the formula of the Doppler shift P cos. Okay. So we are doing the question number, yeah. So we have to calculate what is the value of the ever scenario. One signal is going, both are the going opposite directions, both. So the solution of this question is the 0, because first term we have the cost term, the value of cos beta is 0. In second term we have the cos beta is 180, cos 180 degree. It's come in -1. It's will come 1. So the difference between these two terms is 0. So total Doppler test spread is the 0. Answer is the C part. Next question also correlated. Question is the superposition of given two multipart component result in the constructive interference. So we have to tell which condition is the true. We can comment this question by using this hint. Hint is the calculate the phase difference between two components. By calculating the phase difference, we can comment which condition is the true for the constructive interference. So guys, take your time, try these questions. Okay, so we just calculate the phase difference between the both terms. This is the phase for the direct term. This is the fourth phase for the reflected term. Okay, so by calculating this, we can comment that this is the right term. We can take a common the pi, so it will become 4d fc upon c plus 1. We will go for the constructive interference. This should be equal to 2n pi for the constructive interference. So to make the term, make it in terms of 2n pi, it's follow the nature of the 2z plus 1. It should be odd, because it will be odd, then it will become the 2n pi. Follow the nature of the constructive interference. So answer B is the right part. Next question is also related to previous one. Here we have to calculate the delay spread in the scenario is given by. Here we have to calculate delay spread. Okay. Delay spread is the difference between the maximum and minimum time delay. Okay. The maximum for the reflected term, this is for the direct term. Then we can subtract both the term, it will come 2d by c. So answer is, question is it 2d by c is the D part. Now it is just basic question, the coherence bandwidth is. We have to write the formula of the coherence bandwidth, and we have, according to formula, we have to comment. Mainly we have to note in relation with the coherence bandwidth and delay spread, because all the option is in all option have the term delay spread. The coherence bandwidth, first option is directly proportional to delay spread, inversely proportional to delay spread, independent of delay spread, in non-linear function of delay spread. So answer is the B part, inversely proportional to the delay spread. Right answer B. Next is that in GSM system, which seems to be the best option to prevent the outage because of the channel fading. In GSM system, which seems to be the best option to prevent outage because of the channel fading. What we will do to avoid the channel fading, our system not go in the outage? Basically in GSM we are using the frequency hopping. So answer is the B part. Mainly GSM uses the frequency hopping. FEC handoff, stop transmission till the channel statistics improves. It is the updated version. B part is the right answer for the GSM system. Next question, if a set of sub-carriers in a OFDM system are in fade, which seems to be the better option? Now we have to tell about the OFDM system. Last question related to GSM system. In this question we are talking about the OFDM system. So we have a set of sub-carriers in our OFDM system are in fade, is going in the fading. This seems to be the best option. How we can avoid our system not go in the fade? Option is that do not transmit data on those sub-carriers. B part is the frequency hopping. C is the FEC. D is the none of the above. So in the OBDM, we are using do not transmit data on the dose subcarrier because we have lots of narrow and subcarriers. So we just avoid that terms, avoid this subcarriers. So option A is the right option. Frequency hopping mainly used in the GSM system. This is the last question for the today's session. If anybody have doubt, please ask. Otherwise, we can end our session. Okay. Thank you for joining this session. Okay.